Yesterday, we were looking at factoring polynomials, and we had specifically talked about things like greatest common divisors or greatest common factors. We looked at the AC method, the trial and error method a little bit more, and we talked about the fact that all of our coefficients at this point still had a coefficient of 1 in front of our x squared terms, and today they won't, okay? So we're going to move to that one. This is page 40, yeah. We're on page 40. You should have a page 39 missing right now because it's the quiz that I have not handed back yet. Okay? All right. So one of the things that can happen when we have coefficients that aren't the number 1 is we could have all of our terms have a greatest common factor, like we did last time, except last time we only had 2 terms when we did that. So today we're going to have trinomials, 3 terms, most of them. And the first thing we're going to do as we factor when we don't have an a value of 1, that's the coefficient in front of x squared, is we're going to look and see, do they all divide by something? Do they have a greatest common factor that I can factor out? Okay, so that's our first step. And then once we've either factored that out or determined that it can't have that, it doesn't have that, then we're going to do the same things we were doing before. We're going to either factor with trial and error, which becomes a lot more difficult without that coefficient of 1, or we're going to try the AC method, and I'll show you why that becomes potentially a lot more pleasant or easy to use, practical to use would be the best way to describe it, than when it had a coefficient of 1. But we always start by looking for a greatest common factor. Okay, you guys ready to take a look at some? Everybody has this written down? Fabulous. Okay, so our first example, 5y squared minus 45y plus 90. And if you took me seriously, and you really believed what I said, what is the first thing that you would try to do when you see this problem? What are you saying, Alyssa? Good. Okay, so not divide by, but you are going to pull out a 5, right? Every term here is divisible by 5. So just like the binomials we were doing last time, we're going to factor out a 5. So that looks like pulling a 5 out in front and then dividing each term on the inside by 5. So we'd have y squared minus 9y. Do you guys know what 90 divided by 5 is? It's 18. Good job. Fabulous. Okay, so when we were doing binomials, that was it of the problem. There's nothing else to do. But we're dealing with trinomials. The trinomial that we're left with in the middle here in the parentheses still, at least potentially, and all the ones we're going to do, will factor. Okay? So at this point, and what we're doing in these first few ones, we're going to use trial and error to do it so that you can get a sense of what that would look like if you chose to use trial and error. Now this one is actually pretty nice because when I take out the 5, the y squared that's inside the parenthesis now actually has a coefficient of 1, right? There's an understood 1 right here. So that makes this problem, aside from the 5 I pulled out, look just like the ones we did on the last lesson. So I have a y squared, so there will be a y and a y. Because this is a positive right here, it means my signs have to match. They're either both positives or both negatives. Because this is negative, it tells us they're both negatives. So I know I'm going to have a negative and a negative. And then I need 2 numbers that multiply to 18 and add to 9. What was it? It is 6 and 3. And just as a reminder, we've talked about this before, but how could I know if I actually did it right? I could distribute all back out, right? Multiply everything back out, see that I really get 5y squared minus 45y plus 90 when I'm done, and I will. We did it right. Okay? So the first step is to always look and see, do they all have something they could divide by? Now if I try that on the second problem, do they all have something they could divide by? No. Well, technically they could divide by 1, but that's super unhelpful, right? It doesn't really change anything. So no, there's not a greatest common factor on this one. Okay, so far so good. Unfortunately, that leaves us with a 3 in front of the x squared, which is going to make our life more difficult. So So let's look at what trial and error looks like if I try that with a 3 there. So I need to put values in these first two spots that multiply to give me 3x squared. What would those have to be? 3x and x in the other. Okay, so that part's a given because 3 is prime. If it had been a 4x squared, it's not quite so straightforward, right? I could put in 4x and x, or I could put in 2x and 2x. Because primes are like that, right? Primes have the one distinct possibility here, so I have 3x and x. Just like on the last problem, I have a positive here at the end, which means my signs match. And the negative here in the middle tells me that the signs are both negative. So these are my signs. Okay, so all that's good. So far, we really haven't had to make any decisions. This is what had to happen. However, at the end, I get to make decisions. I have a number 8. So I'd like for you to tell me, what are two numbers that multiply to give me 8? 2 and 4. What else do I have that multiply to give me 8? 1 and 8. Okay, so everybody good so far? That looks like there are two choices that I have in the last two spots. There's actually 4. Let me show you what there are, okay? So please don't write all this down. It's going to look like a mess on my screen for a moment. So one possibility is that I put in 2 here, and I put in 4 here. Another possibility is that I put the 4 in first, and the 2 in second. My third possibility is I put a 1 in first, and I put the 8 in second. And the fourth possibility is I put the 8 in first, and the 1 in second. And to be honest, 8 was not a very big number. Just imagine if it had been a 24 at the end. How many numbers do you know that multiply to give you 24? Quite a few, right? 3 and 8, 6 and 4, 2 and 12, 1 and 24. There's a bunch. So it gets increasingly more difficult because there's more things to try and figure out which one works. One of these works. Do you know which one it is? First one. How do you know it's the first one? How did you check to see?
3x times 4 is 12, and then we have to add the 2x, and that equals 14x.
Okay, so I'm kind of working out a little bit of to the side over here. Was Megan, were you the one talking to me? Okay, that Megan had said. So if I multiply the first term 3x times the last term 4, I get negative 12x. And if I multiply the inside terms, the negative 2 and the x, I get negative 2x. And then when I combine those, I get negative 14 in the middle. That's the check step, right? I got to figure out, does it really give me negative 14 in the middle? And any of the rest of them, they won't. There is a unique solution. It will always work out to being one and only one possibility. So for example, if you tried the middle one here, and I multiplied the first terms together and the last term together, I would actually get negative 6x. And I multiplied the middle terms together, which is the negative 4 and the x, I get negative 4x. And what would this give me a total of? Yeah, negative 10x, which is not what I wanted in the middle. I wanted it to be negative 14. Okay, so there were 4 distinctly different choices that I had at the end. One's right, the other 3 are incorrect. If you choose the right one first, that's fantastic because it means that you're done. If you don't choose the right one first, you have to try another one until you choose the one that does work. And that's where the trial and error part of it gets a little bit cumbersome when we have that coefficients that are different at the beginning. So, one of the things you might be thinking is, well, why did that not happen before? The reason it didn't happen before is because our terms matched at the beginning, right? So when I multiplied the first term times the last term, and I multiplied this one like this out, it didn't matter because these were both 1s here. There was similarity to them, and we don't have that similarity happening right now. One of them was a 3, and the other one was 1. Okay, so that's why this becomes more complicated with that number in front. Okay, let's try another one of them. 7x squared minus 5x minus 2. This is actually a fairly nice one as well because 7 is prime and 2 is prime. Prime numbers are friendlier than composite numbers. because there's less options I have to work with. So if I'm going with trial and error, well, first of all, do they have anything in common, all of them? This one does not. Okay, so if I'm going then with trial and error from there, we always start at the beginning. What two values have to go in my first two spots? 7x and x, right? Now, there is a messier thing involved with this one that I didn't have in the last one. There's a negative here. What does it mean if I'm going to have a negative at the end? The signs are going to be different, right? In order to get a -2, I have to positive and a negative. And if I put them in like this, I might have just put them in wrong, just so you know. I might have to fix that and switch them later. Let me look at what I've got.
I have a question.
Yes.
So why do you put another x in the other parentheses?
Because these have to multiply to give me 7x squared. So if one of them is 7x and the other one's just 1, I won't get x squared. Yep. I wanted to see if I put them in the right way or wrong. I want to put them wrong first to start with so you can see what happens when they're wrong. All right, so pretend I started with this, okay? I already told you they're wrong, but I wanted you to see it, okay? So I have two choices, right? Well, I really just have one choice, 2 and 1. But I have two locations I could put them. I could put the 2 first, or I could put the 1 first. All right? So let's see what happens if I put the 1 first. So what I have to check is I have to check this one. I have to check the smiley face terms. See how I made a smiley face? It's like that. It's cool, isn't it? Okay, so the inside of my smiley face, I would have -1x, right? And the outside of it, I would have 14x. And I want, all said and done, to have a -5 in the middle. Does that give me -5? No, what does it give me? 13. Gives me 13. So that's no good. So the first thing to switch would be the order of my terms. So instead of having a 1 here and a 2 here, I'll put a 2 here and a 1 here. Okay, let's check our terms again. What do I get on the middle? -2x. What do I get on the outside? I get a +7x, right? So what is -2x and +7x? +5x. Is that what I want? No, but it's pretty close. What I want is a -5x, right? So if I get the right value, I'm really pretty much done. All I need to do is to switch where the signs are. So that tells me my signs are simply in the wrong order. If I switch my signs, I will have a negative here and a positive. I said that wrong. Positive here and a negative here, right? Which will give me a positive on the first one and a negative on the second one. So a +2x and a -7x is giving me the -5x that I wanted. Trial and error. Okay. How is number 4 different than the previous couple of them that we've done? Has a negative at the beginning, right? Okay. So negatives at the beginning make it more difficult to, if I just went and put in these numbers right here, I'd have to make one of them positive and one of them negative. That's what I'd have to do. Don't do that, because we're not going to do it that way. That makes it really difficult. So to avoid doing that, what we're going to do if we have it start out negative is we're simply going to factor that negative out. Just like what I did over here with my 5, I factored the 5 out. I'm going to factor the negative, or if you prefer, you can say it's -1. You're pulling a -1 out. So that gives me a +3w squared, a +4w, and then a -4. All the signs switch. Because I don't want to do this. Because then I have two choices. Do I make the 3 negative, or do I make the w negative? I'm trying to eliminate the options. So if I pull out the negative, it makes the factoring easier. That's really my goal. Is how can I do it to make it easier? Because the reality over here is on like number 1, I don't have to factor the 5 out. I mean, we could have worked with it in there, but then I have bigger numbers to deal with, and I don't want to work harder than I have to, right? You guys don't either. So anything that can make our lives easier is what we're going to go with. So it's really just about making it easier to work with. Okay, cool. So the negative's out of the way, which means that the problem becomes much like the last two we did. All right? 3w, or 3w squared. So I have the 3w and the w here, right? All right, so what am I going to have to do with my signs? They're both what? Can't both be negative, because if they're both negative, then a negative times a negative would give me a positive, and this one is a negative at the end. They're going to be different. I need them to give me a -4 at the end. Remember, don't go back to the original question. You want to look at the one that you factored already the negative out of. And with that problem, there's a -4 at the end. So one positive, one negative. So what are my two options that multiply to give me a 4? 2 and 2, or 1 and 4. And there's really not a, hey, it's really in your best interest to try this first. There's really not. You're just going to pick one. You guys told me 2 and 2 first, so let's try 2 and 2. In some regards, 2 and 2 is kind of a nicer way to pick, because if I'm wrong, I don't have to switch them because they're the same, right? So that's kind of nicer on this particular one. And I'm going to make that smiley face to check. So on the inside of my smiley face, I have -2w. What do I have on the outside? I have 6w. Oh my goodness, did we guess the right one? We did. Lucky us. We got it on the first try this time. It works, right? I have -2w, I have positive 6w, and that adds up to the 4w I wanted on the middle. So I'm done. So this would be my factored form. Okay? Okay, if you like trial and error, that's fabulous. Honestly, that is my preference, probably simply because that's what I started learning. That's how I learned to factor to begin with. I kind of like the puzzle aspect of it. To me, it just feels kind of like I'm solving, I don't know, a Sudoku puzzle or something like that, okay? So I like trial and error, and if you do too, that's great. You're welcome to continue using it. If it stresses you out to feel like I keep trying things and it's not working, or I'd rather have something that I just know will always work and I don't have to have a trial and an error to try something else. So if that's you, I'd like to show you how the AC method works when you actually have an A value that's not 1, okay? And we're going to do that by reworking problems 2 and 3. So we're going to go back and do number 2 and number 3, but with the AC method instead. 2 and 3 were both problems that didn't have any coefficients to factor out. 1 and 4 both did, okay? So we're going to check it out. So if I look at the AC method here, I actually multiply A times C. So what is A in this problem? It is 3, and C is 8. So this will give me a 24, right? The B value is 14, -14. Okay, so these are my comparisons. So what I'm looking for is I'm looking for two numbers. I'm going to write this down actually on this one. I want two numbers that multiply to the AC. So they multiply to 24. And they add to -14. Okay, so if they multiply to 24, they have to both be either both positives or both negatives, okay? We got to have that sort of set in our mind as well. There are signs involved here. So what are my options of things that multiply to 24? Let's just write them down. So I could have 1 times 24, right? What else would multiply to 24? 2 times 12. What else? 12 and 2. Okay, what else? 6 and 4. What else? 8 and 3. There's a lot that multiply to 24. Agreed? Yeah, there really are. So I got lots to try. What I need, though, is I need a pair of these, and they'll have the same signs, to give me a 14. Do any of these pairs give me 14? 2 and 12 do, right? Now, I need them to be negatives, obviously, to give me a -14, but 2 and 12 are the right values. So this is the one I want, is 2 and 12. So do you have to write down all the combinations here? No, you don't. If you can just think through them, that's great. But 2 and 12 are what's going to give me what I want. So here's what I do. Actually, I'm going to slide this to the side. No, we'll move it over here for now, and I'll erase it in a minute. we're going to take the negative 14 and we're going to rewrite it. We're going to rewrite it in either order as minus 12x and minus 2x. So if you want to write the 2x first, great. It doesn't matter. Just pick one and go with it. And then I have the 24 at the end. And then I pair them up like I was doing last time. In the first pair, I factor out what they have in common. 3x squared and 12x. What do they have in common? 3x. And if I pull out 3x, what am I left with? X minus 4. Very good. How about the 2x and the 24? They have a 2, and I'm actually going to pull out the negative 2 because I would like whatever's left here, not 2x, sorry, a negative 2. Whatever's left at the beginning to be a positive value. So it'd be x, is it plus 12 or minus 12? It'll be minus because I pulled out a negative. Not 12, sorry. What did I do wrong? Hang on. Oh. There wasn't a 24 at the end. Sorry, this is an 8, wasn't it? I just copied that down wrong. My apologies. Okay, let's fix that. Now I won't get a 12 at the end. I just shouldn't be getting a 12 at the end. If I pull out a negative 2 from the 8, what do I have? Minus 4. I just copied it down wrong, guys. I'm sorry. It was an 8 up here, and it should have been an 8 down there. That was the mistake I made. Okay, and the reason I knew I made a mistake is because what I should have, if I've done it right, is these matching at the end, and they weren't matching. That was my red flag. Okay? Okay, cool. They do match though, right? So I can factor them out in front. We saw this happen in our last lesson. What am I left with then? 3x and then minus 2. Compare that to problem number 2 when we did it with trial and error. Is it the same? They're the same. Good. Very good. Okay, let's try it with the next pair. Okay, so A times C would be what here? 7 times negative 2. It's actually negative 14, so we need to be careful with our signs a little bit. And then the B value is negative 5. Okay, so I need to know what numbers could multiply to give me 14. And it's a negative 14, right? So I could have 7 and 2, with one of them being negative, right? So either negative 7 or negative 2. What else could I have? Just for the sake of argument. I could have a negative 1 and a 14, or a 1 and a negative 14, right? So which of those pairs will add to negative 5? Yeah, the first one I actually listed, right? The negative 7 and the positive 2. So I'm going to take this expression and I'm going to rewrite the middle as negative 7x, positive 2x, and then minus 2. Again, if you put it in the other order, it'll still work. You'll still get the same answer. Paired up, what do the first two have in common? 7x. If I factor out a 7x, what am I left with? X minus 1. Don't forget the minus 1. How about the second one? What am I factoring out of this one? A 2. What am I left with? X minus 1. Do they match? Yeah. Yes, they do. So I have x minus 1 in both of them. So I can factor an x minus 1 out. And what am I left with? 7x plus 2. So that's what the AC method looks like. If you're looking at it and you're like, oh, I'm exhausted just writing it all out, you're welcome to use trial and error. There's actually a couple other methods if you know another method and you want to come chat with me about it, just to make sure that you have the remembering of it right. Let's do that. But, you know, choose your favorite method and go with it, okay? All right, let me show you a couple other things that you're going to encounter in this section. There are some special factoring forms. The first one I'll mention, even though it's kind of silly, I find it to be rather useless, and I'll show you why. But the second one is extremely useful. So the first one's called a perfect square trinomial. If you actually have values that are identical, like this, two factors that are exactly the same, then it will always multiply out to this form, a squared plus 2ab plus b squared. So the way that we're working our problems, we're going to be starting with something that looks like this on the right-hand side, a squared plus 2ab plus b squared. And we could actually go backwards and factor it like this. Okay, so why do I feel like that's kind of a useless one? Well, because all the techniques we've done before would have already arrived at the same thing. This is just one extra thing to sort of try to remember. It doesn't really provide any new useful information. I'll do an example so you can see what I mean. But the next one is very useful. It's called a difference of squares. And this one, again, happens when I have the same a and b, but the signs are switched. One is positive and one is negative. And if you were to distribute this out, you end up getting a squared minus b squared. You don't get a trinomial. And the reason that you don't is because take a look at what happens when I multiply those inner terms together. I get ab. The outer terms together, I get negative ab. So what happens when I add those? Yeah, they add to 0. They cancel each other out. So what's useful on this one is that you're going to have some terms that are going to start out looking like binomials, but each of the values will look like they're squared. So the factoring is really straightforward. All you have to do is the square root of each piece. One of the binomials will be with addition. The other binomial will be a subtraction. All right, can I switch slides? Okay, cool. So here's the first one, and this is the one where I'm telling you I feel like this is a little bit useless. I'm going to use trial and error with it. We've already done a couple AC methods here. So here's a U and here's a U. What are my options for getting 81? At least one of my options, 9 and 9, right? And if I choose 9 and 9, oh, and this is all addition, right? My signs are both positive here. So I've got addition and addition. And if I put a 9 and a 9 in there, will I get the 18U in the middle? I will. But it didn't really require me stopping and saying, hey, look, this one is 9 squared, and this one is 2 times 9. And look, here's that U squared. So I've got that same form that my thing had in, this previous argument. I don't need to know that, right? I just proceed with the problem as though it doesn't matter, because it really doesn't. Okay, so I'd like for you to be aware of it so that when you're looking at it and you're like, in the middle of this lesson, you're going to be like, these problems look way easier than the last, 10 that I did, or well, that's because it's doing this, okay? So they're wanting you to recognize that there's this special form, but it's rather irrelevant. Okay, the other two are a little more interesting, okay, on the screen. So they're binomials, right? I have 25, which is certainly something squared. What is it squared? It's 5. And then the other term is the W squared. So I do need to recognize what is it that they're actually squaring. And because it is a difference, subtraction, of terms that are squared, it's a difference of squares. Super descriptive terminology, right? Difference of squares. Okay, cool. So what does it mean I do? Well, it means I have 5 and W, because those are the terms being squared. One's positive and one's negative. Bada bing, bada boom, we're done. Right? Like that easy, that straightforward. But you have to recognize that you actually have squaring of terms going on. So if I look at that on number 7, what do you see? What is being squared in the first part? 5 and y. So it's 5y. What is being squared in the second part? 7. Okay, write it down. What do you think that this is going to look like then when you factor it? That's it. All about recognition, then the factoring is very straightforward. Okay, I have a couple more examples that are going to feel a little bit different when you first look at them. Are you ready for them? Okay. What is it about these problems that looks tricky? Somebody say it really loud. There's lots of, like the exponents are really big, right? All the exponents we've been doing before have been like squares, or they don't look like they have an exponent. And these have 7s and 6s and 4s, and they look really big, right? Okay, go back to the very top of your notes from this section. Very, very top. What is the first thing you should always look for when you're looking for factoring? GCFs. These have them. So, look at all three of these terms. What is it that they have in common? There's a 3. Fabulous. What else do they have in common? They've got a u to the 5th. So I'm going to take out everything they have in common and see what's left. So I've got 3u to the 7th and I've taken out 3u to the 5th. So what's left? U squared. Minus 10, what? U. Plus what? 25. I thought I heard somebody say 12. 25?
Yep.
25. And the u to the 5th's gone, right? I already factored it out. Cool. Okay. Now, the 3u to the 5th remains. Don't leave him out. Don't ignore him. He's there. He's just, he's finished. The next part is going to be able to be factored. Very nicely, I have a coefficient now of 1 on my u squared, right?
Yes.
That's super nice. So now I can do a u and a u. What are my signs going to be to give me a positive 25 at the end and a negative 10 in the middle? Both minus, and they both happen to be 5s. And if you take a look back at this, it's actually that perfect square trinomial. That's irrelevant to actually working the problem out, right? It is. I've got the 25 giving me 5s at the end and the 5s in the middle. So this is finished. All right, 9 GCFs. What do they have in common? A 2 and a y squared. Right. So if I take the 6y to the 4th and I take out 2y squared, what am I left with? 3y squared. So it's not a coefficient of 1. That's kind of a bummer. How about the 20y cubed? 10y. And the 14y squared? 7. Just 7. Just 7. No y's on that one. Okay, well, the bad news is that there's a 3y squared. The good news is that it's all positives, right? All positives mean my signs are very straightforward. They're both positive. Okay, so what are the values at the beginning of each set of parentheses? What are they going to be? Not 2, 3y, and y. All right, at the very least, I do have, 3 is prime, so I have a 3y and y. I don't have to make any decisions. 7's also prime. So I know I'm going to have a 7 and a 1. It's the only way I get a 7 at the end. I just have to figure out where I'm going to place them. Do I want to place the 7 first or the 1 first? Right? The 7 is 7 times 1. So do you want a 7 in the first parenthesis or in the second one? First? Let's give it a try. If I put a 7 here and a 1 here, you got to check. What do I get in the middle? 7y. What do I get on the outside? 3y. Will that give me the negative 10y in the middle I want? Yes. Yes, it will. They're added, remember? 7 plus 10, or 7 plus 3 is going to give me the 10. So this would be my completely factored form of that polynomial.